Assalamualaikum. So class, in this video, I will talk about definition 4, which is odd components, also for third one factor theorems. First, in definition 4, we have definition for odd component. Odd component of a graph G. Okay, it is a component of graph. That means a subgraph of this graph. It is a component of odd order. We have a component in G and then that component is odd order. Odd order, for example, we have a graph, okay, graph with 3 vertices. So the graph of K3 is actually the graph of odd order 1, 2, 3. Also K5 here 1, 2, 3, 4, 5. This is graph of odd component. It's contain odd number of vertices. So the number of odd component of H ni maksudnya kita ada satu subgroup dalam group. We call it is denoted by capital O of H. Okay, capital O of H. And by third factor theorem. Third one factor theorem. If we have G as a graph and G consists of set of vertices and edges, G has perfect matching. Okay, kenapa kita cakap G has perfect matching? G has perfect matching if and only if for any set of any set S, okay, every set S which is subset of V in G, we have the number, okay, the number of odd component G minus S, it must be less than or equal to the order of S. For the proof of third factor theorem, okay, it is actually a long proof, so you can find it in the YouTube or you can just search in Google on how to prove third one factor theorem. Alright class, now we want to find whether that a graph has or not a perfect matching. A graph is a graph of perfect matching or not. So let's consider one example here. We have path 3, okay, graph of path 3, P with 3 vertices A, B, C. Let's say S is set of vertex A. Okay, S is set of vertex A, and then for the number of odd component in the path, okay, path of 3 minus this path graph minus this set A, kita nak tahu berapa jumlah odd component dalam P3 minus S. So P3 we have these 3 vertices, and then when minus S, maksudnya minus A lah. B minus A here, it's left B and C. One path here. So the number of odd component. This is odd or even. Okay, we have 1, 2. We have 1 and 2. So this is even component, not odd component. That means the number of odd component for this graph, okay, P3 minus S is subgraph of G of this P3, which is 0. So number of odd component is 0 here, which is less than 1. Less than 1 1 ni ialah nilai ni lah. The number, okay, the size of S, which is 1. Also, for S is B, okay, if we have S is set B, and then B, okay, kalau kita tengok kat sini, B, when we remove this, we remove B. So, tak ada B. So, it's left only A and C. Where class A and C is odd component. 1, 2. We have 2 odd component here when we remove B from this graph, from graph of P3. So, we have the number of odd component P3 minus S is 1, 2. So, we have 2. 2 is greater than 1, where 1 for the size of this set, which is violates the third condition. So, P3 has no perfect matching. We can conclude, okay, we conclude P3 has no perfect matching because it's violate the third condition. Third condition, tengok kat sini, the number of odd component for G minus S must less than or equal the number of set S. Now, let's consider another example. We have this graph, and this graph is connected by this point A. So, this is graph G. And then, G minus A. Okay, let's say we remove A. Kita set S ni adalah A tadi. So, we remove A. Then, when we remove A, it's left 1, 2, and 3 odd component. 1, 2, 3, 4, 5. Maksudnya ni adalah odd component. The first odd component, the second one, and this is the third one. So, the number of odd component in G minus A is 1. Okay, kita ada G, A is 1. And then, the number of odd component 1, 2, 3. Kita ada 3. 3 is greater than 1. So, from third condition, it must less than this set. So, kalau lebih besar, it still violates the third condition. As G has no perfect matching.